This is a great, I repeat, great GCF problem. GCF, of course, means greatest common factor. The GCF of 48 and 72 is blank. I don't know it. So this is frustrating. This is going to take a while. This is a long problem. It's a hard problem. If I had to rate it on a scale of 1 to 10, I would say this would be about an 8 or a 9. The only thing it's missing is that it's not a word problem. What makes it hard is that 48 and 72, you can already tell probably these are going to have a lot of factors. So since it's so hard, I'm going to time myself. And let's see how long this would take me if this was an actual quiz or test. So let's see. I'm going to press my start button there. And I am on the clock. So the first thing I'm going to do is do up a little T-chart here. I'm going to draw it up horizontally. I'm going to list out each factor for 48 and 72. So I got my little T-chart listed out there. And now, let's see. 48 is the first number. So the most obvious thing that goes into 48 is 1, and way over here, 48. 1 times 48 is 48. That makes sense. Now, I just use the rules of divisibility. The better you know them, the faster you'll go. Is 8 an even digit? Yes, it is. The last digit even, so 2 will go in. Now, 2 times 24 is 48. I know that because I know my hours and my days. If I have 2 days, that's 24 hours per day, 48 total hours. All right. Will 3 work for this? I'm just going in sequential order here. 1, 2, 3. 3 will work. 4 plus 8 is 12. 12 is divisible by 3, right? So 3 times what gives me 48? Well, 3 times 10 is 30. Let's see, that's 48 minus 30 is 18, so I have 18 left. So 3 will go into 18 6 times. 10 plus 6 is 16. All right. Will 4 go into that? Yes, it will. 4, hopefully you know this by memorization. 4 goes in there 12 times. You should know your multiplication tables up to the 12, so hopefully you know that one. Will 5 go in? No. 5 won't work. Doesn't end in a 0 or 5. Will 6 work? 2 and 3 go in? Yes, it will. 6 will work. 6 times what gives me 48? Well, that'll be 8. Again, that's something you should just know. And 7's not going to work. 7 times 7 is 49. So I know everything in between here. That's as far as I can go. Now I got to do the same thing for 72. 1 and 72 is the most obvious ones to start with. So I'll start there. 2 goes in again. It's an even digit, so 2 will work. 2 times what? 2 times 36. 2 times 30 is 60. 2 times 6 is 12. 60 plus 12 is 72. 7 plus 2 is 9. 3 goes into 9. How many times? Well, I got to know my hours again. 3 times 24. 3 days is 72 hours. All right. Will 4 work? Yes, it will. 4 will work because 100 minus 28 is 72. 4 goes into 100 evenly. 4 goes into 28 evenly. Thus, 4 goes into 72 evenly. How many times does it go in? Well, if we take away the 25 times that 4 went into 100 from the 7 times that 4 went into 28, we're left with 18. So we're winding it down now. 5 won't go in again. Doesn't end in a 0 or 5. 2 and 3 work though. So 6 will work. Again, you should know these. The numbers up to 12 you should know. Alright, 6 goes in. Will 9 go in? Yeah, it will. 9 goes in actually 8 times. So I'll put the 8 first and the 9 second. 10 won't go in, right? Because it doesn't end in 0. And 11 won't go in either. So these are my final numbers here. And I am left with on, let's see, 48. 48 is my biggest number. Will that go in here? No. 24? Yes. 24 is my second biggest number, and guess what? That works. So my GCF is 24. Now I did this in under 4 minutes, and I really took my time with it. I bet I could do it in 2. But you get the idea. Hopefully this helps you with GCF problems. Like I said, it was probably one of the harder ones you can do.